Sentiment analysis is a discipline that focuses on analyzing and determining people's emotion, sentiment, affect, and mood. As we progress towards a world with more human-computer interaction, understanding and comprehending human emotions and sentiment is essential to the advancement of applications and modern interfaces. My project involves evaluating the effectiveness of recurrent neural networks in two different tasks: understanding and identifying sentiment in tweets, and classifying emotion in narrative texts like children's stories. Research into better solution to understanding emotions and sentiment will enable us to build the next frontier of computational systems. Let us now see some of the areas where emotion research has a significant impact. The ability to determine consumer sentiment towards your brand or product provides you with the power to manage your brand. Companies analyze sentiment on messages and tweets on their handles to determine changes in consumer sentiment. This allows them to act immediately if company perception becomes negative. One can also analyze sentiment on microblogging platforms like Twitter to make better stock predictions. Sentiment analysis is also used as a first step in several applications such as text-to-speech systems. It allows the system to understand underlying emotion in text and produce more expressive and natural-sounding speech. In this section, we will give a brief overview of the system used for both tasks. As neural networks can't take words as an input, the first step is to convert words into feature vectors. In our own experiments, we employ two types of pre-trained word embeddings: word-to-vec and glove embeddings. The output of these layers are then fed into the recurrent neural network structures, such as long short-term memory networks, gated recurrent units, and bidirectional RNNs. This is then fed into a hidden layer and a softmax layer to generate conditional probabilities of each class, which allow us to predict the sentiment or emotion. In this project, we have built two systems, one that analyzes sentiment on tweets and another that classifies emotion in children's stories. Using a merged bidirectional LSTM model using word-to-vec and glove embeddings, we were able to accurately predict sentiment in tweets with an accuracy of 58.8%. For the task of emotion prediction in children's stories, we made use of bidirectional LSTM with glove embeddings and were able to achieve an accuracy of 71% on the test dataset. This shows us that bidirectional LSTMs are extremely effective in predicting emotion in narrative texts like fairy tales.